Let's see, apparently today's 18th of November, and as we go through this presentation, you can bear in mind that Cloudbank is a National Science Foundation funded consortium of three universities: University of Washington, University of California, San Diego, and University of California, Berkeley. And we are operating a program that is intended to facilitate access to cloud computing, particularly on the public cloud, um, for research computing or data science. And if you have questions that are not covered here and want to follow up with us, we have a help desk. So you simply send an email to help@cloudbank.org and we will respond to that. The Cloud Clinic is intended as a series of fairly brief presentations on topics that are key to using the cloud effectively. And I'll say more about that in a moment. That's a picture of myself. I consider myself a technology learner, but not a computer scientist, particularly in the area of AI. I'm learning as I go. And so this is really a sort of a step in the process of sort of internalizing this and contextualizing this new and very extensive technology of artificial intelligence. And so I'll talk about what I try and mean by that. And again, I'm coming at this from a point of view of participant in the Cloudbank project, education, outreach, and training. So the Cloud Clinic series is intended to provide some small bite-sized sort of build paths, plus introducing cloud terminology. For a non-technical researcher, we hope to be able to enable a person to build data science CI. CI is an acronym. It stands for cyber infrastructure. So it's the computing and networking and storage and other services that you orchestrate together on the cloud. You pay for this as you go, and you hopefully are facilitating your research. I have three axioms listed here. First of all, that cloud computing is not a simple proposition. That means if you're going to get into it and use the cloud, you're going to have to master some learning curves, and matters are much worse when you start introducing artificial intelligence. But as we'll see, artificial intelligence technology is closely integrated with cloud platforms. Second axiom, cloud use should be efficient. So we would like to help you use the cloud efficiently and spend $1 for $1's worth of compute rather than $20 for $1's worth of compute. That's one of the main sort of grudges against cloud computing, is that it's expensive, and a lot of that has to do with learning how to use it cheaply. And then, of course, there is building a cyber infrastructure that is secure. So I mentioned that this is the 7th Cloud Clinic. The prior 6 are listed here. For example, using preemptible or spot market instances. I talked about data publication and accessing data through an API that you build and run on the cloud. Containerization is an important part of data science and computation. I talked about using object storage in a mode that makes it look like it's running on your laptop. So in other words, if the cloud has an enormous data storage, you can sort of make that look local to your laptop or to your virtual machine that you're working on to sort of simplify your life. And then I talked in Clinic 5 about the Jupyter Hub environment, and in Clinic 6 about bouncing between virtual machines. So this brings us to today's topic, cloud services. And this is just a reference for later use by the interested party. So introducing AI in relation to cloud services and some terminology, skill development, and some peril. That's what we're going for here. And sort of to preempt myself or to steal the thunder of this talk, these are some of the subtopics in using artificial intelligence on the cloud. Part of this is being able to get into AI and to customize AI capabilities for a particular task. There's an important aspect of creating and working integrated development environment, IDE, And particularly, I'm interested in optimizing the use of an application called VS Code and VS Code Server. So I'm going to just parenthetically say that VS Code, when I run it on my laptop, looks like a local application that can see all the stuff files on my computer. It allows me to write code and run code and so forth, and do all kinds of sort of local host operations. But VS Code Server, which is not necessarily broadly understood, is a way of running VS Code through an SSH connection that looks like it's running on a virtual machine on the cloud. So what that means is all the conveniences of the VS Code integrated development environment can exist on a cloud server. Continuing this laundry list of technologies, Hugging Face is a sort of mysterious analog of GitHub for AI models and data sets. Then there's this term agent, which has recently come to my attention. And understanding what an agent means is also an important piece of the puzzle that we're trying to assemble here. And then finally, coding assistance in support of research. And I'll be mentioning a couple things about coding assistant strategies for software development and for context building. So hopefully this is a preamble of terminology that I'll be getting to in the course of the few minutes that I have left here. I wanted to sort of call out two resources for your edification if you're not familiar with them. One of them is a YouTube video series. The channel is called 3 Blue 1 Brown, and this is an educator by the name of Grant Sanderson providing a really thorough and enlightening narrative of what deep learning and neural networks are and how they work, so that sort of becomes a demystified piece of the landscape. And then also the University of Washington eScience Institute has just started instituting workshops around AI. And the AI ABCs workshop, we have a link to that here, both the lesson site and the workshop site. And so that concerns AI interpreted as methods for exploring structured numerical data. And it has subtopics. So this is like a 4-day crash course introducing unsupervised and supervised learning, nonlinear models, optimization, k-means, random forest, neural networks, deep learning, all that kind of stuff. So I wanted to share those as really great resources for the interested person. And now to then pivot to defining the term AI, artificial intelligence. We kind of have an existing or broad sense of the definition, which is related to machine learning, and that's simply analyzing structured data, methods for doing that in sort of an autonomous mode. And then now we have the sort of pivot into AI, which has come to include large language models. And in this short presentation, I'm going to be discussing LLMs as coding assistants. So that's a very narrow focus, and I'm completely avoiding the topic of things like chatbots and other uses of LLMs that are not so directly relevant to research computing. Okay, I'm going to skip this, I think. So let's move on. I mentioned the second definition of AI as sort of a coding assistant. Recently, the University of Washington hosted Dr. L. O'Brien from University of Michigan, who talked about the use of coding assistants by scientists to write code in relationship to things like having to retract papers and stuff like that. And one of her observations was that researchers are commonly not trained to write correct, reliable code, but we are in the position of writing some kind of code that we hope works. So if this is the case, then the coding assistant comes along, and the trick is to use it in such a way, in sort of an informed way, so that it improves the quality of code we write, maintains a high standard, rather than simply is sort of used as a black box that can create code that doesn't work as intended, as we would intend. So there we go. AI coding assistants can help improve code quality and reduce development time in the research domain. They can also assist with building sharing solutions, and I want to digress on what I mean by that. If I have a data system that I can use and my research team can use, that's one thing. But we're increasingly in an age where being able to share that data and share processing methods is to our mutual advantage with our colleagues. And that involves a sort of whole second layer of technology beyond the basics of analyzing the data. And that is the kind of thing that a coding assistant can definitely open the doors to being able to do that kind of open science. Okay, and then, yeah, I think that's probably enough said on that. So the main part of this talk is 4 slides, 4 different aspects of how AI services are built into the cloud and that we can therefore interact with. So this is category number 1 of 4, which is pre-built AI services. So a cloud provider, and I use the 3 large ones, Amazon Web Services, Microsoft Azure, and Google Cloud Platform. And these cloud platforms have built-in AI services that are primarily built to facilitate AI use for somebody who isn't necessarily deeply familiar with the algorithms. And the subcategories that I have here are text and language tools. As an example, Amazon Comprehend, which is sentiment analysis. There's vision and image analysis services, such as Azure Custom Vision. There's conversational stuff, which is getting into chat. And then there's forecasting and analytics. I've given the example of Google Cloud Auto ML. So I've given particular cloud examples of these technologies, but every single one of them has, all 3 clouds will have their set of tools around it. So there's sort of an equivalency, and then there's the question of, is there something special about a particular cloud that can do something I'm interested in? So yeah, these services are built with the enterprise world, the business world, not researchers in view. So therefore, as researchers, knowing that these services exist is the first step to leading to an exploratory journey where you can say, you know, can I make use of Amazon Comprehend? Can I make use of Azure Custom Vision? So that's the kind of the main reason I wanted to do this first presentation on AI in relation to the cloud in this Cloud Clinic series, is to sort of point out these connections and these technologies exist. Slide number 2 of 4, we have foundation models. And foundation models and related technologies. So for example, the Claude large language model would be considered a foundation model, as is Gemini, Jurassic, and so on. You can read all of these. And then, of course, there is customization of these models by giving additional prompt input in the RAG format or doing model fine-tuning. And then there's coding assistance. So this is kind of the core of the AI on cloud platforms. Probably goes without saying, but each cloud has this respective suite of foundation models, and then you set up access and you pay as you go based on your usage rate. I mentioned earlier the term agent. Agentic AI is sort of a transition from the initial kind of chatbot world where you were getting, you were sending in prompts to the AI or the language model, I'll say that, language model, and you were receiving back sort of suggestions or ideas or explanations. But we've now kind of pivoted into this agentic world where the AI starts to get tools to do things. So you go from this world of suggesting answers to questions or suggestions to the AIs can actually write code and save it and run it. And then there's this further on the spectrum, the AI can go off to the internet and examine internet pages. Often these actions are predicated on you, the user, giving permission to do the next step. And then there's even now composition of agents where you use multiple agents or sub-agents to take on different roles in performing a complicated assembly task. So, for example, you can build a software project where you have 4 agents, one of which is dedicated to writing code, another one writes comments, a third one writes test code to test what the other 2 are doing, and the fourth one maybe evaluates the final result as manifest in a web app. So this agent spectrum, I just wanted to sort of call that out as something to be aware of. That is also a huge learning topic. Okay, this is a quick intermission on testing and validation of AI-generated code. Part of the material here comes with a conversation that I had with a student I work with who interned with X and XAI, those 2 companies, over the course of the summer, where he was sort of thrown into the deep end of the pool, writing a lot of prompts for AI to write code for the job that he was doing. And so this is now sort of standard procedure. And from his point of view, the first rule of working with an LLM to write code is something called multi-shotting, which is probably familiar. It simply means iterating with the LLM in the process of writing something rather than trying to give a single directive to sort of complete the task in one go. So another point that my intern friend student makes is that if you're going to be using a language model to write code, it's really important to have an extremely precise picture of both the input and the output of the process that you are undergoing, that you're designing. Start by writing tests from the outset. Writing tests means code that can execute and test the code that you're actually building. And then data quality testing is sort of an interesting topic unto itself. But basically the idea is it's, again, an iterative back and forth process. And the example here would be if you were going to go off and analyze, let's say, some atmospheric data, and you have a sense of what it looks like, then you want to anticipate when things go wrong and be able to encode that in the software that you're building, so that when the data that comes in that you're processing in due course has anomalies in it, that you have some chance of catching that. So that's a quick glance at some, let's say, what we hope to build as the best practices for working with a language model as a code assistant to generate code. Okay, this is slide number 3 of 4, which is different types of interacting with the cloud for artificial intelligence. And this is the machine learning platforms that are provided by the various cloud providers. So Amazon Web Services machine learning platform is called SageMaker. And inside of that, there's a whole bunch more terminology that I didn't want to belabor, but the important word is Studio. That seems to be a commonly used term, although Google uses Workbench. So Google has Vertex AI and Workbench. And the language model that's sort of behind this for Google is called Gemini. For AWS, they tend to use the Claude language model. And then Azure uses like ChatGPT or the OpenAI suite of language models. But the point is that these cloud providers are setting up a managed working environment that's sort of let's say it's a Jupyter environment that connects to these other services and has a lot of this connectivity built in, so that you're sort of off and running in a working environment that already knows about PyTorch from the beginning. So the last sentence here is, sorry, I'll look at this paragraph here more carefully. These managed AI ML platforms include Jupyter, example PyTorch. They integrate coding assistance, then they integrate with other key services such as data storage. And they are also potentially very expensive. So at the very beginning, I talked about using the cloud in a cost-effective way. And the first step in being cost-effective on the cloud is to understand what you're paying for the services you use. So there we go. And then second intermission here, I wanted to mention this as an opportunity that's not necessarily obvious, but it's a good example of what AI coding assistants are capable of. So if you set up a coding assistant that can go out and look at the web, then you can choose a research domain and choose a corresponding science gateway. An example at the bottom of the page here, I used something called PODAC, which is Physical Oceanography Data System. And that's sort of owned and operated by JPL, NASA JPL. And you can say, okay, I'm going to try and get data from PODAC, but instead of going and trying to sort out how their API, their application programming interface works, I'm going to have the coding assistant do that. So you point the coding assistant at the documentation online for the particular science gateway that you're interested in. And then you say, okay, read this and then build a interactive API code that goes and gets data sets, and then help me visualize that. So this is a really interesting kind of recent, I don't know how recent it is, but anyway, it's an interesting development in how we approach using coding assistants and language models in general that are capable of going off and internalizing content on the web. Okay, and the last slide that I have here is AI on Cloud Platforms 4, and that's infrastructure and compute power. And this is really kind of a pro forma slide where I'm just talking about normal cloud technologies that are related to the use of AI. So we have virtual machines and, very importantly, GPUs. GPUs are a little bit problematical. If you start to dig into this and use the cloud for GPU access, you may run into permission restrictions that have to be lifted. And that's one of the things that we do in the Cloudbank project is we work with the cloud providers to make GPUs accessible and available to our researchers that we're supporting. And then the clouds have support for containerization. They have custom hardware, for example, Trainium and Inferentia, I think, are the terms for the custom hardware on AWS. Of course, there's unbounded capacity data storage, databases from across all common architectures, and so on. So that's the fourth of my 4 slides on the relationship between AI services and cloud providers. There's a little bit of a graphic here that just sort of follows through the process. I was doing this yesterday on the Google Cloud Platform, where you are reminded that you need to turn things on, like the Gemini large language model, before you can actually use it. But here's sort of a series of screen captures that track going through, starting on the Google Cloud console, and then choosing the Vertex AI, let's say, environment, and then turning on a workbench, and then getting estimated cost, and then opening the Jupyter Lab is the last step at the bottom. So this is sort of working your way through the console into a working computing environment. And this is a screen cap of the Jupyter Lab at the end of that process, where I selected in particular a PyTorch-enabled Jupyter environment. Okay, I'm going to skip over that, and I'll just end up with my conclusion here. So we have all of the cloud providers competing to be the go-to AI. This works to our benefit. And of course, they're not doing this for research. They're doing this for the business world. So we have to sort of fill in the gaps to how this can be applied to the research we're interested in doing. Okay, so this presentation is our simple point of departure for further